we're reminded that in an NPN transistor circuit like this, when you put a positive voltage here, a current flows from the base to the emitter, and that causes a larger current to be able to flow from the collector to the emitter. The consequence of that is that when there's no current flowing this way, the potential at VC is just plus 5. There's no current through this resistor, therefore no voltage across this resistor, and therefore the voltage here is still plus 5. When we put a lot of current this way, we can effectively close a switch from collector to emitter. The voltage across here becomes no greater than VCE sat, maybe a fraction of a volt, and this voltage then declines to near 0 volts. So it has this inverting feature that positive input here makes this go more negative, more closer towards 0. Now the problem asks, put a triangle wave in over here and arrange that an LED goes off when the triangle wave goes high. If you put your LED in the collector branch there, it's the opposite effect. When there's a positive current through here, when the triangle waves goes high and there begins to be a current here, now there's a current here and the LED lights. So that's not where we want to put that LED. Bad place to put it. However, the voltage at this point goes down as the triangle wave goes more positive. So here's the triangle wave. Here's 0. We want, in this region, to have the LED go off. This voltage goes down as the input voltage goes up. So the first thing to do, and many people did just this, is to simply add your LED right there. That works, and we have to adjust it now so that this occurs only, that the LED goes off at just the right moment. First thing to know is, what is that moment? When is it going off? It's hard to see it, of course. So we'll connect this up to scope B for a moment. Here's scope channel A. And how are we going to adjust this point? There are a lot of ways. People tried putting different resistor values here, 10K, 20K, whatever. This might be 1K. You could do that by trial and error. Some people also did this. They just attached this to the wiper of a potentiometer, and the input signal A was now here, the triangle wave going in, and so they could adjust this until the right thing happened. Before we go on to look at the scope trace, B is not really monitoring the current through the LED. It's monitoring the voltage at this point, and we can guess that when this voltage is high, the LED is on. But it would be more accurate to measure the actual current, and one way to do that is to insert a resistor here. Hardly matters what resistance. I'll say 10 ohms. It could be 100, could be 1,000, and monitor this point instead of that. Now, whenever there's a current through the LED, there's a current through the resistor too, and this, what you monitor on scope channel B, will reflect that current. We need to adjust the potentiometer here until we get just this, that the LED, the blue trace current, is going off just at the moment where the triangle wave goes through in the positive direction through 1 volt. And for that, we need to trigger, shown here, be sure to be triggering on scope channel A, the yellow curve, and also I've set the trigger level up at 1 volt so that this occurs right where we want it to, right here. That's the point, that's the trigger point, and you see that the input yellow curve is going through 1 volt right at that moment.